So in this section, we're going to be looking at radioactive decay. So in this radioactive decay, what we're looking at is often we're looking at radioactive material and we're seeing how long it takes for the mass. So in this case, 50 grams. So we're saying, hey, how long does it take for 50 grams to go to 25 grams? Because that's half of 50. So that's what this example right here is looking at. So if we look at it, so we're looking at something decaying. If we start off with 10 grams, we're saying, well, how long would it take to be cut in half? So half of 10 would be 5. And then it's half of that amount, which would be 2.5. And then half of that amount. And then so it just keeps going half and half and half, but half of the previous amount. So that's what we're looking at. We're only going to be looking at a half life. So what you're going to want to do is go to your formula package. So go to your formula package, go to the exponents part, okay? And you're going to be looking at radioactive decay. And so instead of FP like you had for the growth, which was looking at population of bacteria, we're looking at FM for mass. What's the future mass? So the weight of it kind of thing. So we're saying the future mass is equal to the present mass bracket 0 0.5. So we're always going to be dealing with half-life. So how long it takes to go in half to the exponent of t over h. So t is how much time we're looking at, and h is the time that it takes for it to be cut in half. Okay, so let's just copy that out. So we have Fm, future mass, is equal to the present mass, 0 0.5, that'll always be there, to the exponent of t over h. Okay, so in this case, I'm saying it's going to be cut in half after 123 years. So after 123 years, that 50 will finally be down to 25 grams. Okay, so that 123 is the denominator, the H, the half life. Okay, so let's just plug this in. So we've got future mass is your present mass. So I have 50 to begin with. This 0 0.5 is always there. And we're saying that it takes 123 years for it to cut in half. And then for number 9, we're saying, well, how much do I have after 369 years? How many grams do I have? So that's your T. So that's what I'm looking for. Okay, so when you do this, you're going to want to figure out the exponent part first. So I do 369 divided by 123, and that's 3. So what that means is we're looking at 3 cycles of 123 years. So that means it the 50 was cut in half, which is 25, and then that 25 was cut in half, and then whatever that answer was, that was cut in half. So you could do that, but the quick way is just go zero point 0.5 to the exponent of 3, and so I got 0.125, and then just times that by 50, so follow BEDMAS, and I get 6.25 grams. So I'm saying that after 369 years, this 50 grams of product, okay, this material that was 50 grams, it's decayed and it's only down to 6.25 grams of radioactive substance. So that's what this graph right here shows. The decay rate could be differently. This one shows a small decay rate, whereas this one shows a much faster decay rate. So it doesn't have to be always cut in half. That's all we're going to deal with in this class, but it could be decaying by a quarter. So that might be this one. This one could be a quarter. Okay, so if it only goes down a quarter in value, whereas this one could be half and this one could be 3/4, whatever, it doesn't matter. Okay, let's look at number 11 real quick. So 41 years. So we got future mass. So we're still starting the question with 50. We started off with 50. 0 0.5 is always there, but now we're looking at 41 years. So 41 is up here. Now the bottom is always 123 because that's how long it takes for it to cut in half. So what you're going to do in this case is still do the exponent. So 41 divided by 123. I get 0.3 repeating. So just so that you're somewhat close to the right answer, make sure you go 4 decimal places. 1, 2, 3, 4. Okay, and that'll be close enough. If you've got the answer key on your calculator, even better. So you're going to go zero point 0.5 to the exponent of 0.333. That's all I'm going to use. And then I'm going to multiply that by 50. Okay. So that's not a full cycle. So your number should be bigger than 25 because remember, this has to be 123 for this 50 to go down to half. We haven't done half yet. So I should have more than 25, and I do. I have 39.69 grams. And that's it.